Good morning, everybody, and welcome to our SPHN webinar of today. We start a new webinar, a short webinar series with this webinar today, and this is dedicated to the 5 university hospitals, this series. In the course of the past years, the 5 Swiss university hospitals, with support from the Swiss Personalized Health Network Initiative, have built up clinical data management systems, so clinical data warehouses or lakes or data platforms, to ensure the sustainable data availability for primary, but most importantly, secondary usages. The SPHN funded projects like our driver projects, or also the ongoing national data streams, help driving these infrastructures and their development. And of course, the populating of the clinical data management systems. You know that there is an increasing need of routine health data from the care setting for research, but also other secondary purposes. So those infrastructures are really crucial when it comes to a time and also cost-efficient provisioning of data. So the next 5 webinars will be dedicated to our 5 university hospitals that will present their infrastructures and their contributions towards the widely desired Swiss health data ecosystem that we hear a lot about these days. Our first speaker is Dr. Bram Stieltjes. Bram is head of the Personalized Health Basel and also responsible for the data platform of the University Hospital in Basel. Thank you very much, Bram, for taking the time. We are very much looking forward to learn about the status quo of the hospital IT at the USB, about the gaps and challenges, and of course, are keen to hear your future outlook on things. Thank you, Bram.
Yeah, thanks, Catherine, for the introduction. And hello, everybody. I can't see you, but I saw at least that there were a few people joining already. Yeah, so Catherine already kind of outlined the work that the hospitals have done in the context of SPHN, and also mentioned that actually it's not only about research data, but a lot of secondary use. And I hope that I can show you some of the secondary use, but also what we did. And the first thing I wanted to start with is this image. And I really think that what we are trying to do inside hospitals and also between hospitals in the context of SPHN is really trying to move a big elephant. And actually it are maybe several elephants. One thing is that basically thinking about data quality as a routine element of clinical work is something that is not natural to my colleagues in medicine. And so that's one big elephant, is like, okay, how can we show another that for clinical purposes and for research purposes and for many other purposes, it's valuable to change maybe the way we work. That's one thing. And it's really a big elephant to move. And then there's another big elephant, and this is sharing data. And I'm not talking about the legal and ethical aspects, but really about the desire to share data. And there's a big discrepancy between what people tell you if you ask them and what they really do. So I've learned over the last, let's say, 6 years or so, that usually my biggest challenges are not technical in nature, but are more, let's say, political, psychological in nature. And it's really about creating also culture where the importance of sharing of data, both for patient good and also for research, and sometimes these two coincide, is really something challenging. And SPHN is lasting only until the end of next year, and maybe even right now already people are thinking, okay, was it worth all the money? And then the question is, what are you going to look at? Only at the infrastructure or not? But why I want to introduce or start my talk like this is that what I'm totally convinced of is that SPHN helped us, let's say, bringing these elephants on the table and started to move it. And without it, we would have done nothing. I'm pretty sure that we would still also conceptually be exactly at the same place where we are. And I think that's of tremendous value, regardless of how much infrastructure we build or did not build, or where we still have flaws. I think that's an important point. Nonetheless, I will, try to give you an overview of all the elements that we built. So this is basically a first slide. I will go through all the elements step by step and talk you through. But so in red, basically you see the core part we started building in the beginning, and that's the USB data warehouse. And I'll talk about it a little bit later, but basically there we try to consolidate all the data that is recorded in clinical systems that is somehow structured. So there's also different ways of thinking about it, but it's basically about the structured data that can get in there. And we have about 200 applications that we try to connect the most important ones and find the data, but I'll talk about that a little later. Then after a while building the data warehouse, we start seeing that it's for smaller hospitals often difficult to build their own data warehouse. So I will also briefly address what we're doing for the Children's Hospital here in Basel is a data warehouse as a service, and I had to do it because this abbreviation dwaas in Dutch means idiot, and maybe it was a little bit of an idiotic thing, but now we're really starting to progress there, and I hope that it can be a model for other places maybe as well. Then if you have a huge amount of data, there's a large amount of applications and portals you can put on top of it. Applications here, there's business intelligence platforms. We are thinking about synthetic data platforms for sharing. And then on the left-hand side, there are SPHN connectors specifically. So they're not hospital specific, but SPHN specific. And I will talk about them and their value in this context as well. A little bit of trouble moving forward. So I will first start addressing this core, so the data warehouse. This is a slide that shows you elements of a data warehouse. And basically on the bottom, you see that all our source systems are clinical source systems. Like I said, there are about 200 individual applications. And the problem of these applications is they store the same thing, like a blood pressure, in different ways. So if I want to analyze blood pressure as a whole, I need to kind of bring this together. And that's basically what happens from here to here, the integration layer. So there we have a model of blood pressure, and we map all the blood pressure models of each system to there. And so it's a huge effort because the vendors of the software also every now and then change their way they describe data. And then basically we have to redo a lot of the work. So this is also just one take-home message is even if you have a data warehouse, you're never ready or finished because of the underlying applications changing the way they're dealing with our clinical data. But now we have about 350 to 400,000 patients in the data warehouse. Considering that Basel has less than 200,000 inhabitants, it's a quite considerable amount of patients, and we have hundreds of millions of data elements accompanying these patients. Now, of course, you can have it, but what can you do with it? So, sorry, I'll get to that later. So the other part is that, like, it's a lot of work to model all these source systems to one data warehouse model. But once you have it, actually, you can really take that as a good input to start building a data warehouse for another hospital, because there's overlap in applications. And to instantiate a new, let's say, mandate on your existing data warehouse, we learned it only took us 2 days. And then if the other hospital uses the same software, like in the children's hospital, they use the same laboratory system, they use the same radiology system. So everything we already mapped, we can basically already bring along. And we only have to map those systems that are not present. So that's really exciting about the project with the UKBB, because we feel that at very low cost, we can actually heave another hospital on the same level. So that's, I think, really something that makes data warehouses scalable to some extent. And I'm really hoping that once we've been able to show this for one hospital, that maybe other hospitals will also say, okay, we couldn't have afforded a data warehouse on our own, but if we could work together with a university hospital, it could become more attractive to do so. So then there's a whole layer above, if you want, the data warehouse, wherever data that you've ordered in a structured way can then be readily sent to. So there's applications. Now in the last year, we built a whole business intelligence platform on top of our data warehouse. And so we can, with that, send emails, reports. Actually, yesterday we had a large discussion in the SPHN context about triggers. So we can take data from systems and then based on that data, send reports. And we've recently also opened it up in a way, the term is called business intelligence self-service. So basically we can build little data marts for researchers to explore on their own. So also trying to get away from people just requesting data by a ticket to us, and then we make a package and we give it to them. And then if they don't like the package, there's discussion again. And so there's a lot of work involved in data delivery that we can take away with such a self-service platform. And the next slide or so, I will show some examples of what you can do at this layer. So sorry for this slide being in German, but like one of our internal customers, if you want, from the hospital is our billing department. They often get questions back from the insurer if we were right. And one example was blood products. And there were a lot of questions back. And basically we had all the possible raw data to make a report, which really reduced a lot of their work in documentation towards insurers. That's just one of many examples in that realm. And I think that's also an important point. I think we could show over time that the work also done in the context of SPHN as a side effect also improves hospital core business. And I think this is also important for, say, the sustainability of it all. Then the other thing I want to show that we also use the data warehouse for. So this is, again, this landing zone where we basically have copies of the data from these primary systems on the bottom. And then here we have structured data in the transformation layer. And we tested clinical decision support software, actually both from Siemens and from Roche, to not do this in a live environment where we would have to do a lot of engineering. Actually, the data warehouse provides a nice base to test such clinical decision support software that are very hungry, not for doctors' letters, but for discrete data elements. Now, the sad thing we learned, and I think that's really an important point, is that even for clinical decision support from our own, let's say, data, only 30% has such a quality that it can be directly fed into clinical decision support systems. and 70% we had to extract using natural language processing. And this 70% then becomes highly uncertain. And in the end, we never got over, let's say, the research and development stage with these products, neither from Roche nor from Siemens, not because the products were not good, but because we could not feed them with adequate data, because such data was just not present. So it was maybe present in a letter, but it was not present stably. And I think this is a huge point. And I wanted to show you this example to show also some of the first gaps that we're still having, is that a lot of important data is not structured, and projects need it, and it's a huge overhead to create it in a structured way. So at the end of the talk, I'll tell you what our response is to this problem. But first, I also wanted to talk a little bit about, let's say, the SPHN specific connectors. So there's two elements today in place. Let's say there's the federated query system. It's served by a product called Clinerion, so where you really can search our data and at least get back if we have patients that meet your requirements. I think it was a huge effort to get all the university hospitals to agree on one platform. I think that's already, an important learning, that sometimes this needs to be done. And yes, the platform has its limitations, but it's also working quite stable for a long time now. On the other hand, there's the desire for more data, and also for data in a fair way. And in the SPHN context, it was decided that this data should be delivered in an RDF format, which per se puts quite some work on the hospital side. And to address that, all the hospitals have worked together with the Zurichen lead to build a connector that basically accepts structured data and then creates the appropriate SPHN files. And that's, I think, another example. So both of these are examples where we could manage to agree on one central piece of infrastructure that all hospitals will commit to. And I think that's of extreme value. And I hope that we will find ways to continue to decide like this. And I think the federated learning is now at an interface where we might come up with a federated learning platform that we all will use to also address that topic in a more concerted way. And just wanted to point out one federated learning project on imaging that SPHN really strongly pushed, and also with the help of our local biomed IT node, we could get to run a large international study on radiation therapy target planning that was run on the SPHN infrastructure. And so I think we found really some good examples of how such an infrastructure could also help us position us in an international stage. Sorry. Now, another topic I wanted to briefly touch upon is the dealing with raw data. And I can already say that we have many gaps there still, but where we are strongly developed is in the extraction of imaging data and how to work with that. So there, we've built a crawler on both imaging metadata that gets sent to the data warehouse. So this metadata is also searchable in the data warehouse. But the same crawler is also connected to our backup imaging storage, so that we can, with the same, let's say, front end, also select large amounts of raw data in this case images, and send them to a dedicated R&D environment where then we've built annotation tools, we can deploy machine learning algorithms, and we basically even build a deployment environment for these algorithms in a clinical routine after training. So that's really an exciting part that honestly we're already doing and could integrate in the SPHN context. And as I said, we did this federated learning platform experiment on radiation planning with similar tools. And then after training algorithms, of course, you can start extracting from images or from any other raw data elements that can go directly into decision support, research, and R&D. So again, as opposed to a letter, algorithms can provide you with a great level of detail that otherwise is difficult to access. And then having that whole infrastructure basically helped us in the COVID period to, within a few weeks, basically find appropriate data to train algorithms for infiltrate detection, and then deploy an algorithm that could automatically quantify COVID infiltration in lung CTs. So for me, the algorithm part is here not the message, it's the speed. It's really like having such infrastructure. We can make huge cohorts in minutes, and we can move data in an hour or so, train algorithms really within a day, and then deploy them. So that's, you know, doing this per se is not so difficult, but doing it in a clinical environment and being able to roll it out, I think it's really something special. And I think that was like the whole building of the infrastructure was strongly inspired by SPHN. Oh, I'm sorry again. Now, I've been talking about the, let's say, data quality more or less indirectly a few times. And I think if I had to name one big, let's say, gap that we have to sustainably provide healthcare data for research, but also for other secondary uses from a hospital point of view, it's basically the unstructuredness of our data. And this has bothered me both in, let's say, the research context, but also in the clinical context, as I quickly already alluded to when I showed the clinical decision support system. And I think the fundamental problem really comes from software that we buy in a hospital. And as I was already explaining, everybody that builds software has a proprietary model and keeps on basically trying to close that model as much as they can, or make money for delivering data to us. And about 2.5 years ago, we really started exploring like how could we change that pattern in order to be able to deliver high quality data without high cost. Because now basically for a lot of projects, even things like diagnosis, allergies, and so on, are then structurally captured by a study nurse or even some medical experts afterwards. So they're reading letters, they're reading reports, and then they bring it into a nice shape. So that's the last block I want to talk about is the clinical data repository. So basically the data warehouse is an analytic repository, but because it's the only place where we have highly structured data consistently, actually we're running some apps that I would rather not run there because they are somewhat in the clinical realm. And the clinical data repository would hold in the future structured data where we can run apps in real time, clinical applications. And we've identified basically an expression language called OpenEHR and a technical implementation of this standard And I just want to quickly show you what we did with it and what impact it had in the end. So we decided to look at a tumor board preparation and decision making, because this is a field where a lot of information from different places comes in, and from clinical routine we know that basically doctors working in the context of a tumor board, nurses working there, their main job is copy pasting out of a lot of systems, all kinds of elements again and again. And so we looked at that case. Oops. Did a workflow analysis of what is being done by whom and what data is important. Then we looked at the modeling language. Then we picked basically two scenarios. So that's basically the data capturing for preparing the tumor board. And then basically the second place is just a tumor board where you just want to decide and you don't want to search for data. And then we simulated the transfer of all data to the cancer registry. I have to say simulated because when we designed the project, we found that the cancer registry had a FHIR implementation of their data. So FHIR is a data format. And in the end, we found out it's not operational. So we build our own FHIR server to pretend that the cancer registry already has it. And we're now in discussion with our cancer registry on how to move forward on this. But what we wanted to see is, okay, if we build a workflow like this, can we find elegant data capturing in the clinic? Can we get away from copy pasting? And does it work in a beyond hospital process? In this case, the cancer registry. And we found, say, a commercial provider of such a platform that basically hosts OpenEHR in an industrial fashion with better. And the FHIR server we already had, so we basically used it. And these are just some screenshots from basically small applications you can build out of the platform, showing structured fields. Although the doctor just typed in Hodgkin and then you see lymphoma, you can take it. And then the other is a partial screenshot of the second use case. So basically just the decision making. And it's just saying, okay, it's just giving this piece of information to the central data repository or the clinical data repository. And in the next use case, this view basically just picks it up. So you don't have to copy paste it. The only open field is then your decision in the tumor board. And behind all this, already integrated in the solution are codes that we normally would have to kind of do manually. So there's ICD-10, ICD-03, but also SNOMED coding for locations and things like this. So there's a lot that is already captured that you don't have to see, but is usually valuable for later on homogenizing the data. And then the last screenshot is just how you can also easily transform this to FHIR if somebody would want to use FHIR as a standard. And this was more of a like, okay, how can we get away from basically having to type? This is basically clickable visualizations of lymph nodes. And again, there behind that, the location is coded in SNOMED. So it's all steps towards elegant structured clinical data capturing. So basically really closing that gap from, let's say, 70% unstructured data towards maybe 70% structured data. And with that, I would like to kind of point out some potential gaps that I still see. So basically the biggest gap is still here in the structured data capturing, I would say, if I had to pick one. The good thing is with this proof of concept that was financed with SPHN money, we could convince our hospital that when we tender our new hospital information system, we will have it commit to this standard. So that's really a huge impact. If you think about elephants, this is a whale. I never thought we could make it, to be honest. But we did. And I think you won't see today, but I think in 3-4 years, it will have a huge effect on the amount of structured data that we will have. Then I talked about raw data. Because we've already worked on that, have strongly developed the imaging part. We have now started to look at electrocardiograms. But for instance, with NGS data, it's still a huge mess. There are several sequencers. They all have their own data storage. So these are things that's still like, how do we deal with raw data? How do we make it available? Is a huge question and a very interesting one. Then we also once, as a prototype, built a federated learning infrastructure, but I feel that we are still lacking a lot. Also because, I think the importance is huge, because I think more and more institutes would rather have their data reside in their institute and then have something done on a closer infrastructure than sending it around. And federated learning platforms would strongly reduce the problems around that. And so I think there's a lot to be done there. The synthetic data, I think, is another interesting approach to see if we can make data more readily shareable. But I think federated learning and the raw data, if I would have to say so, are let's say the 3 biggest gaps, and we are all addressing them together, I guess. So I would like to conclude with the statement, at least, that I feel that we moved the elephant, and quite a lot more than I would have ever hoped. It's really a difficult task. I think it should be highly commended that people are still motivated, also in the SPHN organization, to try and move these institutes closer to each other and with a stronger focus on, well, really working for a whole healthcare system. And I would say with that, I'd like to conclude, and I'm open for questions.
Thank you very much, Bram, for this comprehensive overview. We have some questions in the chat that I will read out to you. I also